Hi, Jim Shaw here from Crystal Group. Wanted to spend a moment just talking a little bit about some new and exciting technology that we've got here in terms of video encoding and decoding. We've teamed with Matrox to basically ruggedize some of their products for applications. And the Navy actually came to them and asked them to partner with us to basically provide this service, and so they're using these kinds of product on some of the ships and subs. And so what we're actually doing here, and let me just run through the process. We've got a signal generator down here, and the signal generator is essentially creating a 4K signal. And then the 4K signal is going out to a splitter. It's actually a duplicator, and it's creating 4K streams from the signal generator. And then those 4K streams are going into this crystal unit, which is a ruggedized Matrox unit. And then what's happening from there is the ruggedized Matrox unit is essentially encoding those streams, 4K streams. And here's where it gets interesting. They're taking those 4K streams and they're dumping all of that information into this crystal server down here, and that's actually done over a 1 gig interface. So let me repeat that: 4K streams on a 1 gig interface, and all of that's happening with less than 50 milliseconds of latency in between the input and the output. So if you think about that, that's essentially 50 milliseconds regardless of distance over Ethernet, and it's a 1 gig Ethernet. A lot of companies are having to use 10 gig for this particular type of video transfer port, and this is being done on a 1 gig. So I'd like to introduce Jeff Dixon here. Jeff is one of our tech directors here at Crystal Group, and Jeff kind of spearheaded this project. So Jeff, what is it that allowed Matrox to be able to do this so efficiently? How does this work?
Well, so inside each one of the boxes, there's an FPGA card built into that. A lot of their secret sauce and how they actually encode, decode, and deal with all the signal conversions as well as the compression algorithms are run in there. Obviously, that's all their proprietary part of the box. What they did is they built a standard box that would go in most COTS products areas, would go into a server farm or more of a less rugged environment, and it worked fine. The problem is when you need more rugged, they didn't have the answer, so they came to us and asked us basically to build the box around their existing hardware that enabled that same capability in the same form factor to achieve what they're doing on a COTS world for the military environment.
If I understand you correctly, Jeff, the kind of the secret sauce here is really the compression engine combined with this FPGA or application-specific IC that are basically, those two together are creating the ability to transport a large amount of video data over a 1 gig port. Is that right? Correct. Okay. Tell us a little bit about the KVM option that we have here.
So the keyboard video mouse option is another product that we actually also did the ruggedization on. It uses a lot of the same FPGA and fundamental codes. The difference is that's encoding for signals for decoding. This is actually doing full encoding and decoding of a full KVM control. So keyboard, video, and mouse over the same 1 gigabit Ethernet interface. You can do RJ45 as well as SFP fiber to get further distances. Okay,
and again, the same compression capability.
Same compression capability.
So you're doing all of this over a relatively thin pipe or a 1 gig interface.
Correct.
Right. And how is this being received in the industry?
We've had a lot of interest in it. Obviously, the Navy had already been using it. We've actually also talked to gas and power companies that do remote monitoring of some of their different distribution points. We also have talked to potential putting it on oil rigs. So basically, any place you want to have some type of video control, but you don't want to sit at.
Right. Okay. And the encoding is, that's one of the benefits, because you're essentially encoding the signal for security reasons.
Absolutely. There's a lot of signals I don't want somebody to intercept en route. I don't want to be where the signal is being generated, but I want to be able to see the full signal at my remote station without the worry that somebody en route is capturing that.
Yeah, okay, and so again, I think the benefit here is you can do this on 1 gig interfaces. You potentially can take transit cases worth of equipment and condense it down into very small packages. It's more portable. It's certainly now rugged, and we can reduce the power, the weight, and the entire footprint of the system. So, thanks, Jeff. Appreciate it. Hope this was useful. And if you have any additional questions, please visit our website, and we'll try to help you out. Thanks.